Hello, everyone. So, this is the continuation of our discussion on the fundamental trigonometric identities. So, here we will be discussing the other trigonometric identities. So, the first one is the sum and difference identities. Okay, so we will be having identities for sine, cosine, and tangent for this sum and difference identity. So first, let's have the sine. Okay, so sine, sum, or difference identities. For sum, we will have this sine of a plus b is equal to sine a cosine b plus sine b cosine a. Okay, while for the difference, we have sine of a minus b is equal to sine a cosine b minus sine b cosine a. So we will just apply these formulas whenever you will have to evaluate the sine of the sum of two angles or the difference of two angles. So here, A and B are different angles. Okay, so let's try to have examples for this one. So we are going to evaluate the following. We have sine 75 degrees and sine pi over 12. For us to use the identities for sine, okay, here, we must rewrite this 75 degrees and pi over 12 as a sum or difference of two angles. Okay? So if you are going to write that one as the sum or difference of two angles, we can now apply these formulas here. Okay? Now, 75 degrees is actually the sum of 30 and 45 degrees, right? So therefore, we can just write 75 degrees as 30 degrees plus 45 degrees. So we will now have sine of 75 degrees as sine of 30 degrees plus 45 degrees. Okay? So take note that 75 degrees is not a special angle. So you cannot directly solve for the value of sine of this angle without using calculators. But since 75 can be written as 30 plus 45, and 30 and 45 are actually special angles, so we don't need calculators for this one, right? So using the formula, since we have 30 plus 45, so we will use the sum, okay? So the identity for the sum. So we will now have sine of A cosine B plus sine B cosine A. So our A here is actually 30 and B is 45, right? So from that, we will now have sine of 30 degrees, our A, times cosine of B, which is 45 degrees, plus sine of B, which is 45 degrees, and cosine of A, which is 30 degrees. Okay, so from that, we will now have, so evaluate now sine 30 degrees, and that is just equal to 1 half, right? So we have 1 half times cosine of 45 degrees is just square root of 2 over 2, right? Plus sine of 45 degrees is also square root of 2 over 2, and cosine of 30 is just square root of 3 over 2. Okay, so from that, we will now have 1 half times square root of 2 over 2. This one is just square root of 2 over 4, plus square root of 2 over 2 times square root of 3 over 2 is just square root of 6 over 4. So from that, we will now have square root of 2 plus square root of 6 all over 4. And this is now our final answer for this problem number 1. Okay, so I hope that is clear. Now, the same with number 1. For number 2, we must rewrite this pi over 12 as sum or difference of two special angles. Now, pi over 12 is just the difference of pi over 4 and pi over 6, right? So pi over 12 is the difference of pi over 4 and pi over 6. So we can just have here sine pi over 12 as sine of pi over 4 minus pi over 6. So there. Okay. So from that, using the formula, the second formula, since we are having here the difference of two angles, right? So we will now have sine of A. Our A here is pi over 4. Cosine of B, our B is pi over 6. So we have pi over 6 minus sine of B. So we have sine of pi over 6 and cosine of A, which is pi over 4. Okay, so from that, we will now have sine pi over 4 is just square root of 2 over 2. And cosine of pi over 6 is just cosine of pi over 6 square root of 3 over 2. Okay? Minus sine pi over 6 is just 1 half. And cosine pi over 4 is square root of 2 over 2. Okay? So from that, we will now have square root of 2 over 2, multiply it by square root of 3 over 2, that is square root of 6 over 4. Then minus 1 half times square root of 2 over 2 is just square root of 2 over 4. And our final answer will be square root of 6 minus square root of 2 all over 4. So this is the answer for number 2. Okay, so I hope that is clear. Now, for the cosine identities, we will have the following formulas. Okay, so cosine of A plus B is just cosine A cosine B minus sine A sine B, while cosine A minus B is equal to cosine A cosine B plus sine A sine B. Okay, so let's try to apply these formulas in evaluating the following expressions. First, cosine 7 pi over 12, and second, cosine of 165 degrees. The same with what we did in the examples for our sine. We must rewrite the given angles here as sum or difference of two angles. Now, 7 pi over 12 is actually the sum of pi over 3 and pi over 4, right? So from that, we can rewrite this one as cosine of pi over 4 plus pi, oh, wait, plus pi over 3, right? So from that, we can now have, so since we have addition here, so we will have the sum identities for cosine, and that is our equation 1. Okay, so we will just have cosine of A, which is pi over 4. This is our A. This is our B. And cosine B, which is pi over 3. So since we have plus here, we will use minus here. So we have minus sine of A, which is pi over 4. And sine of B, which is pi over 3. So from that, we will now have cosine of pi over 4 is just square root of 2 over 2. And cosine of pi over 3 is just 1 half, right? Minus sine of pi over 4 is just square root of 2 over 2. And sine of pi over 3 is just square root of 3 over 2. So from that, we will now have square root of 2 over 2 times 1 half is just square root of 2 over 4. Minus square root of 2 over 2, multiply it by square root of 3 over 2, that is square root of 6 over 4. Or this is just simply square root of 2 minus square root of 6 all over 4. Okay, so that is our final answer for number 1. Now for number 2, 165 degrees, we must rewrite this one as sum or difference of two special angles. 165 is actually equal to 120 degrees plus 45 degrees, and those are special angles. Or you can also have 210 degrees minus 45 degrees. Those are also special angles. Okay, so here I will just use 210 and 45. Okay, so from that we will have cosine of 210 degrees minus 45 degrees. Okay, so there. Now, using the formula, since we have minus, we will use the second formula. So we will have cosine of A, which is 210 degrees, cosine of B, which is 45 degrees, plus sine of A, which is 210 degrees, sine of B, which is 45 degrees. So from that, we will have cosine of 210 degrees is just negative square root of 3 over 2. And cosine of 45 degrees is just square root of 2 over 2. Plus sine of 210 degrees is negative 1 half. And sine of 45 degrees is just square root of 2 over 2. So from that, we will now have negative of square root of 6 over 4, then minus square root of 2 over 4. Or this is just simply negative square root of 6 minus square root of 2 all over 4. So this is our answer for number 2. Okay? Now for tangent identity, we will have the following formulas. Okay? So that is for tangent of A plus B and tangent of A minus B. Now let us try to apply the following formulas in solving the following expression. So first, we have tangent of 5 pi over 12, and second, we have tangent of 15 degrees. Okay, so here, tangent of 5 pi over 6, take note, 5 pi over again. Now, for the formula, for tangent sum or difference identities, we will follow the following. Okay, so we will have tangent of A plus B, that is equal to tangent A plus tangent B all over 1 minus tangent A tangent B. And for tangent of A minus B, we will have tangent A minus tangent B all over 1 plus tangent A tangent B. Okay, so let us try to apply the following formulas in evaluating the following expressions. So we have tangent of 5 pi over 12 and tangent of 15 degrees. Now, 5 pi over 12 can be written as the sum of pi over 4 and pi over 6. Okay, so therefore, we will have tangent of 5 pi over 12 is just equal to tangent of pi over 4 plus pi over 6. Okay? Now, using the first formula, since we have sum of two angles here, we will have tangent of A. So our A is 45 while our B is pi over 6. So we have tangent of pi over 4 plus tangent of pi over 6 all over 1 minus tangent of pi over 4 times tangent of pi over 6. Okay? So from that, we will now have tangent of pi over 4 is just equal to 1. So just check that 1. Plus tangent of pi over 6 is just square root of 3 over 3. Again, check that 1. All over 1 minus tangent of pi over 4 is 1. Tangent of pi over 6 is square root of 3 over 3. So from that, we will now have 1 plus square root of 3 over 3 all over 1 minus square root of 3 over 3, right? Now, let's try to simplify this one. So let's combine the terms in the numerator and also in the denominator. So we will have in the numerator, the LCD is 3. So this will become 3 plus square root of 3 over 3, right? All over. For the denominator, LCD is also 3. So this will become 3 minus square root of 3. Okay? So there. And this will now be equal to So 3 will be canceled out. So we will have 3 plus square root of 3 all over 3 minus square root of 3. You can have this one as your final answer, or you may rationalize this one to get the simplest form. To rationalize this one, we will just multiply the expression by the conjugate of the denominator. So we will have 3 plus square root of 3. So you will just change the sign here. Okay, so we have 3 plus square root of 3. Now, 3 plus square root of 3, multiply it by 3 plus square root of 3. Just check this one. The answer is 12 plus 6 square root of 3. All over 3 minus square root of 3, multiply it by 3 plus square root of 3. Just check this one. This is equal to 6. Okay, simplifying. So the numerator is divisible by 6. This will now be equal to 2 plus square root of 3. So we will now have this as our answer. Okay, so that is for number 1. Okay, so we have 2 plus square root of 3. Now let's try number 2. Tangent of 15 degrees. Now 15 degrees can be written as 45 minus 30, right? So we can have this as tangent of 45 degrees minus 30 degrees. So from that, using the formula, the second formula, since we are having minus, right? So we will have tangent of A. Our A here is 45, our B is 30. So we have tangent of 45 degrees minus tangent of 30 degrees all over 1 plus tangent of 45 tangent of 30 degrees. So from that, we will now have tangent of 45 is just equal to 1. Just check that one. Minus tangent of 30 is just square root of 3 over 3. All over 1 plus 1. Multiply it by tangent of 30, square root of 3 over 3. Okay, so we will now have 1 minus square root of 3 over 3 all over 1 plus square root of 3 over 3. So from that, we will have, combining the terms in the numerator and denominator, we will have 3 minus square root of 3 over 3 all over 3 plus square root of 3 over 3. Okay? And this will now be equal to, so 3 will be canceled out. So we have 3 minus square root of 3 all over 3 plus square root of 3. You can have this as your final answer, or you may rationalize this, multiply the given expression by the conjugate. So we will just change the sign here to minus. So we have 3 minus square root of 3 all over 3 minus square root of 3. So from that numerator, multiply the expression. So we will have 3 minus square root of 3, multiply it by itself. So this is just equal to 12 minus 6 square root of 3. Please check that one. All over, this one is just equal to 6, the denominator. Okay? And simplifying, we will have 2 minus square root of 3. This is now our final answer for number 2. So we have 2 minus square root of 3. So those are the formulas for the sum or difference identities for sine, cosine, and tangent. Okay? Now let us solve the next identity, and that is the double angle identities. Okay? So here we have two formulas, that is for sine and cosine. Okay? So for sine 2 theta, we will have this formula, 2 sine theta cosine theta. And for cosine 2 theta, that is equal to cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. So we have three formulas for cosine 2 theta. The other two formulas are derived from the first one, this one. Okay, so let's try to derive take note from our Pythagorean identity. Um, we have sine squared theta plus cosine squared theta is equal to 1, right? So it will follow that sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta, right? So from that, we can actually replace sine squared theta by this and cosine squared theta by this. So let's try first to replace sine squared theta here. So we will have now cosine squared theta minus, so sine squared theta is just 1 minus cosine squared theta, right? Distributing the negative sign, you will have cosine squared theta minus 1 plus cosine squared theta. Now, we have 2 positive cosine squared theta, so we will have 2 cosine squared theta minus 1, which is our second formula for cosine 2 theta. Okay, now let's try to substitute cosine squared theta. So we will have here cosine squared theta is just 1 minus sine squared theta minus sine squared theta. So from that, we have 2 negative sine squared theta here. So this will now be equal to 1 minus 2 sine squared theta, which is our third formula for cosine 2 theta. Okay, so that's it. Now, let's try to apply the following formulas here in solving the given problem. So, we have given sine theta is equal to 3 over 5, and theta is between pi over 2 and pi. Find sine 2 theta and cosine 2 theta. So, here, since the angle theta is between pi over 2 and pi, the angle theta is located at quadrant 2, right? So, therefore, from that, um, our sine is positive and our cosine is negative, right? Now, solving for sine 2 theta, we have the formula 2 sine theta cosine theta, right? But we only have the value of sine theta. We need to solve for the value of cosine, right? Now, from our Pythagorean identity again, um, cosine squared theta is just equal to 1 minus sine squared theta, right? So it will follow if we are going to take the square root of both sides, we will have cosine of theta is just equal to plus minus square root of 1 minus sine squared theta. And since our angle theta is in quadrant 2, the value of sine should be negative. So our formula will be cosine theta equal to negative of 1 minus sine squared theta. So this is the formula that we are going to use to solve for cosine. So from that, we will now have cosine of theta is equal to negative of 1 minus sine squared theta is just equal to sine theta squared, right? And sine theta is equal to 3 over 5. So we can have this one as 3 over 5 squared, okay, using the given value of sine. So from that, we will now have negative of 1 minus 9 over 25, right? And this is just equal to square root, negative of square root 16 over 25, or just negative of 4 over 5. So our cosine is equal to negative 4 over 5. So from that, we will now have 2 times sine. Sine is 3 over 5, so we have 3 over 5 times cosine, which is negative 4 over 5. So from that, we will now have 2 times 3 times negative 4. That is just equal to negative 24 over 25. So this is now our answer for sine 2 theta. Now, how about for cosine 2 theta? Using the formula, you may choose either of the three. So I will just choose the first one. So we have cosine squared theta minus sine squared theta. So you will have cosine is negative 4 over 5. So since it is cosine squared, so you have negative 4 over 5 quantity square minus sine squared theta will be 3 over 5 squared. So from that, we will have 16 over 25 minus 9 over 25. And that is equal to 7 over 25. So that is our final answer for cosine 2 theta. Okay, so that's it for double angle identities. Now, for the last identity that we are going to tackle, we will have the half angle identity. So we have two formulas for this one. That is for sine and cosine. Okay. We also have formula for tangent, but we will no longer include that one here. Okay. So sine theta over 2 is equal to plus minus square root of 1 minus cosine theta all over 2. And cosine theta over 2 is equal to plus minus square root of 1 plus cosine theta all over 2. Now, observe that the formula involves plus minus. Okay, so this one only indicates the sign of sine and cosine, okay, depending on the location of the given angle. Okay, so we will still apply the sign of the sine and cosine, okay, depending on the quadrant, okay, the quadrant where the angle is located. Okay, so let's try to apply this one. So we will evaluate the following. First, we have sine 22.5 degrees and cosine 22.5 degrees. Now, here, 22.5 degrees is just half of 45 degrees, right? So we can just write sine 22.5 degrees as sine of 45 degrees over 2, right? Since 22.5 degrees is just half of 45 degrees. So therefore, we already have this form. Okay. Now, what are we going to use? Is it plus or minus? Take note that 22.5 degrees is located at quadrant 1. So it is located at quadrant 1. Therefore, the sign of sine in quadrant 1 is positive, right? So therefore, we are just going to use the positive sign. So we will have 1 minus cosine theta, which is 45 degrees, all over 2. Okay? Now, evaluating this one, we will have square root of 1 minus cosine of 45 is square root of 2 over 2, right? All over 2. Now, simplifying this term here, so just check this one. So this will now be equal to 2 minus square root of 2 all over 4. Or simply, we have square root of 2 minus square root of 2 all over 2. So this is your answer for number 1, sine 22.5 degrees. For cosine 22.5 degrees, the same process. We can have this one as cosine 45 degrees over 2. Okay, so again, 22.5 degrees is in quadrant 1. So the sign of cosine in quadrant 1 is positive, right? So we will have 1 plus cosine of 45 degrees all over 2. So positive square root. Okay, so from that, we will have square root of 1 plus cosine of 45 square root of 2 over 2 all over 2. And this is just the same as square root of 2 minus square root of 2 all over 4. Okay, so just check this one. And simplifying, we will have square root of 2 minus square root of 2 all over 2. So this is your answer for number 2. Okay, so that's it. So that ends our lesson on trigonometric identities. So I hope everything is clear. Thank you for watching.